This is question 18 from section 9.10, and quite honestly, this might be my favorite problem in the geometry book. I particularly really started liking trig when I saw this problem because it just occurred to me how incredibly powerful trig is. These little simple equations with only 3 parts allow you to do so many things. So hopefully in the previous videos I've occasionally talked about the idea of indirect measure. I think I did a little bit with the tree problem. Just to kind of remind you that the whole idea of indirect measure is sometimes there are things that are difficult to measure by hand, and using geometric concepts such as trigonometry or similar triangles, we did with the flagpole types of problems, finding lengths of shadows, that kind of thing. Sometimes you can take geometric ideas and you can use it to make measurements that maybe you can't make by hand. So for example, the height of a mountain. You don't particularly want to climb to the top of Mount Everest and drop a tape measure down and see how tall the mountain is. And it turns out you can actually make a lot of measurements using angle measures, and angle measures are much easier to measure. So that's what's going on in this question. Okay, we've got, I think, some surveyors out. They're trying to figure out how tall this mountain is. Perhaps I should call the height of that mountain X. And actually, you know what, it's vertical. I'm going to call it Y for a reason you'll see in just a second. So, anyway, we're going to say that that mountain is Y units tall. And they tell us a couple things. One surveyor, it's way out here, measures a 30-degree angle of elevation to the top of the mountain. Okay, all that person knows is how far it is to the top. Okay, notice this person doesn't even know how far it is to the base of the mountain. Okay, somebody 1 kilometer closer has a little steeper angle to the top of the mountain. Their angle of elevation to the top of the mountain is 35 degrees. Okay, now you have to have a length measurement somewhere. The only length measurement they know is that they're a kilometer apart. Okay, that we get a 5-degree change in the angle measure a kilometer apart. Okay, and notice this triangle's not a right triangle. It's an obtuse triangle. And so on the surface, you think, well, you know, how is this even a right triangle trig problem? Well, the key is, number one, you have angle measures. Number two, we're trying to find the altitude of a mountain, and an altitude typically is going to be perpendicular to the ground. And you can see that you can kind of make a right triangle here. One right triangle has a 30-degree angle. We have another right triangle here that has a 35-degree angle. And then toward the back of this assignment, you're going to see several problems where you have multiple right triangles. All right. There's one other thing that I think is going to need to come into play here, and I think we saw this back in 9.4 when we were working with some of the other right triangle problems. I think we need to know something else about sides. We're saying that this side is Y. We know a piece of this side. We don't know this entire length here. Now, I'm going to call that X. All right. Here's my approach. You have 2 right triangles here. Okay, I would always draw those right triangles separately and see what you've got. All right. So if I take this right triangle and I draw it, I have a 35-degree angle, okay? I don't know this side, it's Y. I don't know this side. By the way, I'm letting X represent that whole length right there. That length is X, okay? Doesn't seem like enough information to solve anything. And by the way, it's got 2 variables, okay? All right, for the second part here, I have another right triangle. I have this longer, thinner right triangle with a 30-degree angle, okay? And so you can also draw that triangle. We've got a 30-degree angle here. This whole side length is X plus 1. Okay, we've got a right angle here, and it has the same height as the other triangle, it's Y. Okay, now by the way, this is a 30, 60, 90 triangle. Okay, and unfortunately, since I don't have any full lengths, I don't think that's going to help me at the moment, but that could come back into play at some point. All right, so putting all this together, I have a couple things that I don't know the length of. I don't think the hypotenuse length is going to be important here, but I do think because we have a horizontal length, I think this length will come into play. Currently, we have 2 variables, all right? And of course, we know from Algebra 1, if you have 2 variables, typically you're going to need 2 equations to be able to find a solution. We also saw that back in section 9.4, all right? We have 2 right triangles, though, like back in some of the problems in 9.4, which means we can probably write 2 equations. All right, so let's take a look at what we've got here. We've got angle measures and we've got sides. We should be able to write trig equations. And in particular, we have an opposite side and we have an adjacent side. If you think about your SOHCAHTOA rules, opposite and adjacent means we can write a tangent equation. So I'm going to write two equations here. I've got a tangent of 35 equation. Tangent of 35 is going to be equal to the opposite side over the adjacent side, y over x. Okay. And second of all, I've got a 30-degree angle here. I've got an opposite side and I've got an adjacent side. The tangent of 30 is going to be equal to y over x plus 1, right? Opposite over hypotenuse. Okay? Now, on the surface, this still looks terrible, all right? But remember, tangent of 30 has a value. Tangent of 30 has a value. We could actually find tangent of 30 without a calculator. But anyway, the point is those are just decimal values. So to take yourself from the point where you're not psyching yourself out here, I would suggest go ahead and find those tangent values. So tangent of 35 is about 0.7002. Okay, so that's about 0.7002. And again, if you can keep the decimal completely in your calculator, I think that would be a good idea. So 0.7002 is equal to y over x. All right, and tangent of 30, if we run the numbers on that, tangent of 30 is about 0.5774 if you're rounding. Again, it really is best if you leave it in your calculator. Anyway, but if we do that, these are suddenly a little bit simpler. And the thing that I'm noticing here is I could get this equation equal to y pretty easily, and I could get that equation equal to y pretty easily. And then we'd have two different equations equal to y, which means they should be equal to each other. So I think I'm going to solve both of these equations for y. I'm not saying it's the only way you can do it, but I think that'd be a good idea here. Y is being divided by x. I want to get rid of the x, so the opposite of dividing by x would be to multiply by x. And so we get one equation here that says that y is equal to 0.7002x. Okay? This one, a little bit more going on here. We're going to have to multiply, we're dividing by x plus 1, so we're going to have to multiply by x plus 1. And that means we're going to have to multiply by x plus 1 over here as well. And so, anyway, 0.5774 is getting multiplied by x, and it's getting multiplied by 1. So we're going to have 0.5774x plus 0.5774 when we distribute through is equal to y. Okay, this is equal to y, that's equal to y, which means they should be equal to each other. So 0.5774x plus 0.5774 is equal to 0.7002x, okay? And again, it's just a little algebra 1 equation now. It looks ugly, we got decimals, but really not very bad. So, I'm gonna put all my x's over on this side. So I'm gonna subtract this 0.5774x from both sides. And again, I would use your original 0.702 decimal there. That's actually the tangent of 35, and I'd use the actual 0.577 decimal, which is actually the tangent of 30, if you want to type it in again, or if you just want to highlight it on your calculator. And anyway, we're going to get approximately 0.5774 is equal to about 0.1229x, okay? Again, really I'm keeping that decimal in my calculator. I'm going to divide both sides here by 0.1229, and that tells me that x is approximately equal to, let me run those numbers real quick here. Okay, so this is coming from the tangent of 30. So the tangent of 30 decimal, which I have the whole thing in my calculator, divided by the 0.1229 decimal. It's going to tell me that x is approximately 4.699. Before you just stop the problem and end up missing it, make sure you've got a good diagram and think about what you just found. X is actually this length right here, okay? So we haven't actually finished the whole problem yet because they want the height of the mountain, okay? However, we now know that we've got a triangle that has a 35-degree angle and a 4.6999 side, okay? And that's this triangle back up here. So I'm going to go ahead and fill that in. And we should be able to close this out now. Notice we've got an angle, we've got a side, we're looking for another side, and if we solve that equation, we should now be able to find the value of y. So let's go ahead and do that. We've got an opposite and an adjacent. It's going to be a tangent of 35. I guess technically we're substituting back into this equation here, is equal to y over 4.699. So we're going to multiply both sides by 4.699. Okay, so take that full 4.6 whatever decimal you've got in your calculator and multiply that by the tangent of 35. And we should, when you multiply 4.699 times the tangent of 35, you should get approximately 3.29 is equal to y. Remember, that's in kilometers. And don't remember if they ask you to round, but I think 3.29 is, do they ask you to round? They say find the height. Doesn't look like they say. So anyway, in the book they rounded to do decimal places, so we'll go with that as well. So about 3.29 kilometers high ends up being the height of the mountain. But I love this problem. I mean, look what's going on here. We have these simple trig equations that only have 3 parts. A little bit more complicated because you've got a system and you had to figure out what to have variables represent and that sort of thing. But amazing that a person can measure just the angle to the top of a mountain, and the other person can measure the angle to the top of the mountain. And if they know how far apart they are, a distance they can find on the ground, on their odometer on a car, that sort of thing, they can figure out how tall a mountain is. Really powerful stuff.